With any visual effects shot, we start with a concept. Here is one that was illustrated by Alan Bettino from the art department at DreamQuest. It shows a very large horizon about 2 miles across, a vantage point from the Notre Dame Cathedral as a large asteroid comes in and hits the horizon. This would cause a large tsunami of Earth. An asteroid traveling at 44 miles per second, which is what this one was traveling at, hitting the Earth would perform as a fluid. Here's a scene from like a scientific magazine that might show an artist's concept of what the Earth would do during an impact. From that, Michael was very excited and we began developing storyboards. This shows more of the idea of the motion through the scene as it comes in. From there, we did a very quick animatic, only spent about a day or two, to give the idea of motion. Here you can see the large wall of Earth coming toward the camera. This is very important because, again, we have very little time to produce a shot, and also it's made up of literally hundreds of little pieces that go together to make a shot work. So having this approved, we moved on to the next step. This is what the shot looked like from just the camera original, which is high-speed photography of an explosion. This is a very unusual type of explosion using very fast 5,000ths of a second hits. We started with the idea of using CAD. This would be a very large tabletop miniature, about 100 feet across by 90 feet deep, and using concentric rings of primer core. There are 80 hits here. There's over 6,000 feet or several cases of dynamite all going off within 0.4 of a second. In order to facilitate this, our engineering department, with Joe Hagee and Fred Iguchi, we built a computer system that would control up to 96 relays via computer. So we could take the timings from the digital animatic and load that into the computer here, and it in turn would fire each ring of the concentric circles of the explosion. In order to produce a large explosion like that, we found Hansen Dam to be the most suitable place. Here we built a large tabletop of Earth. Using large machine graders, we would actually grade the area to be at an 8-degree slant so we could look over top of the Hansen Dam toward the natural sky. It took only a day and a half to go from ground Earth to building a tabletop. Once the Earth was flattened, we used large steel plates. These are 8 feet by 20 feet, weighing several tons apiece, and laid them and field welded them into position. This was necessary so we could produce a nice hit for the rings to go off of. This is important to produce the actual effect of the explosion coming skyward. Here you can see the concentric rings being laid down. Each one is a piece of explosive cord that is taped and glued into position. There are 80 of these going out to several hundred feet in length. Once we had this completed, we then began wiring up the detonators. The detonators were required to explode the primer cord, but not actually be seen on camera. These have to be specially made and hand done. Safety, again, was a big issue. Here we're using the general materials. It's sand, about 14 inches of sand placed on top of the primer cord, as well as mulch and a little bit of Fuller's earth for texture. This was kind of experimented to figure out the right heights and thickness to produce the size of the wall of earth as we needed. Here you can see them connecting up each one of the rings through a laced cable, and this cable then terminates down toward the computer ending. We had a large fiery explosion at the beginning, which was done with aluminum powder jettisoned from those canisters. This is required to produce a large flash of light that you see in the film. Here inside the steel bunkers where the housing of the computer is, and again, Richie Helmer, who is head of the Pyrotechnic group, actually works on working with our engineer in producing the sequence. Again, there's 5,000ths of a second interval between each one, which appears at real time as one continuous explosion. With some tests, we continued working. We had a crew in France waiting to shoot the plate, but again, because of time, we had to shoot the background before we shot the live action. This required users compass headings and clocks to be able to figure what time of day to shoot so that the two pieces of film would match. Building an armored bunker, we put the high-speed photosonic 4E cameras in and waited for the right weather. A little bit of testing to make sure everything was working right, and this was something that we again used high-speed video to analyze because most of the events went off so fast you really couldn't see them in real time. Once we got the shot set up and everything was green lit, we waited for weather. This is what the shot looked like in real time. It took place in 0.4 seconds. From the side, slowed down 5 times, you can see it race toward the camera position. But on screen, what it produces is an amazing effect. It looks like a giant wave about 1,500 feet to 2,000 feet high coming at the camera in 15 seconds. Therefore, we produced the initial part of the elements required to produce destruction of Paris. The idea of gargoyles was something that Michael Bay really liked. So our art department drew up a bunch of gargoyles and then with some selected began sculpting them out of gator foam. This was a hand-done process. Most of these did not have to break away except for one, and that one was cast out of a vermiculite material and cabasol that would break apart on cue. Here you can see them painting and detailing. We've essentially built a whole upper set piece that will be shot in VistaVision as a foreground blue screen element. Great detail was made in terms of aging to make it match and look like the real thing. They were made as breakaway pieces so that air cannons and some pyrotechnics could be used to blow them apart on cue. Here, rehearsing with video assist, we're able to actually have things like earthquakes and rocks, and you can see the idea of these pieces being broken. It took us several days of work to get the effect, and it's quite messy, as you can see when it fires. We shoot all kinds of material, cork and dust and dirt. It makes a real mess of the stage, but it produces a very interesting visual effect as the wave actually reaches the camera position and destroys it. Here you can see in real time what the effect looked like as it blows the gargoyle apart. Using aerial photos and satellite photos, Chris Keene started building an actual block feel of the buildings that we'd eventually see shot from the Eiffel Tower. Even though we shot from the Eiffel Tower, the illusion was that we were somewhere else high above the Paris background, and we'd later put in the Eiffel Tower as a CG element. Using the block diagrams and shapes made in Maya, we then projected the footage that we shot from our plate crew in France onto those shapes. Those shapes were then used with particle technology and dynamics to tear apart to create the dynamic effect of the buildings actually imploding. We took a virtual cylinder, and by passing that through the plane of the buildings, we're able to give the illusion that the wave is actually coming out and breaking. You can see here in the lower frame that the bits and pieces of the buildings are being broken up into particle pieces as the wave comes toward the camera. This is a digital trick that helped make the illusion look real. Very special buildings built by Adolf was something that we put in too, such as the Eiffel Tower and certain prime buildings in the Parisian horizon. This is necessary to be able to have ultimate control over the shapes, and also to assure that the audience at a very quick glimpse would know that we're actually looking at France. Again, these CG buildings were built to fall apart and come in sync with the actual wave as it came toward the camera. Here you can see the pieces break apart and the thing fall over as a separate element. When combined with the compositing techniques, it looks quite real. Blaine Kennison, head of our compositing team, took the 50-some-odd elements and in about a week and a half put them together on film. The digital asteroid with its trail, the interactive lights on the clouds and on the horizon were intricate and very necessary to give the illusion of reality. By putting in some pigeons on blue screen and by putting the camera move in, we got a very realistic-looking shot of a large 2,000-foot wave of Earth coming in and destroying the camera. Here again you can see the basic parts, starting with the Eiffel Tower. That was combined with other buildings that break up through particle technology as you take the maps and break them into pieces. The actual wave front, the skirt of destruction as it comes toward the camera. And then when composited, it gives a very interesting and kind of realistic shot of what it might look like if a giant asteroid came in and hit the horizon of a Paris skyline.